to talk about. One is domain and range, and the other one is composite functions. So we've looked at functions. We've been able to calculate g of a particular number or f of a particular number. We've been able to calculate like g of x plus 3. We've been able to calculate g of x plus h. What we want to look at when we talk about domain and range. Right now you are used to, if you were to create an XY table of values or of points, your first column would be X, your second column would be Y. When we talk about domain and range, it's still just referring to the same thing. Domain is your X value. Range is your Y value. Input versus output is another way that we could refer to them as. Input is your domain. Output is your range. Domain is what are the X values. Range, what are your Y values. Another way you could see Y, your input could be X, your output could be f of x, because f of x means the same thing as y. So your domain is x, your range is f of x. If you were to look at a graph going on the horizontal or the x-axis, this is your domain, while this is your, let's see if I can write sideways, is your range. So given a graph, it's pretty easy to determine what the domain is. Look on the x-axis. Wherever it goes on the x-axis, that's your domain. Now, as you talk about domain, there's two particular concepts that you really need to look for, and you're going to get into this in the other math class. Domain, there's two things you have to be worried about, because there's two main things that we cannot do in math. One thing that we need to be concerned with is that you can't divide by 0. So you never want the denominator to be 0. Any value that makes that denominator 0, if you have any value that makes the denominator 0, that is not in your domain then. Your domain is everything except what makes it 0. What's the second thing you can't do in math? No, you can rationalize that. I know that Saxon doesn't like you to divide by a radical, but if you go to UNL, they're okay with a radical in the denominator sometimes, and I know that because of their placement test. But it does have something to do with radicals. What can't you do with the radicals? You can't take the square root of a negative number, because that then turns into an imaginary number. So we want any values. Your domain would be anything that does not have division by 0, and any values that do not allow you to have values less than 0 in your radical or as your radicand. So those are two things we need to look at and be concerned with when they start talking about domain and range. If you're given a graph, let's just say you're given a graph that, let's try to come up with something. I'll just do that. If you have a graph that looks something like that, and if I asked you what is your domain, there's different ways you could state your domain. One of them is in set notation, and in set notation, That's where you're going to have your braces. Interval notation, you'll be using brackets and parentheses. And set notation, and it's interesting because Lindsay's college algebra, they had asked her questions for the domain and range, and then it says in interval notation. She puts them in interval notation. She goes to class and she goes, well, Mom, they're wanting it. She gave us examples, and the examples she gave us, and she said it's okay if we put it in set notation. Her set notation varied just a little bit from the way that Saxon writes it, but it still represented the same thing. I think it just dealt with a slash, or X is all reals instead of X is an element of the reals. So same concept. So in set notation, domain is your X values. So if I look at this graph, -5 is included in my graph, and that's my end spot. My graph does not go beyond -5 for the X values. But if I look at the higher end of my X values, it goes from -5 inclusively, because it includes that value, but it's going to keep on going beyond 10 because my graph keeps on going down. So I can go beyond 10. So the way you could state it is X is an element of the reals such that X is greater than or equal to 5. That's one way you could write it in interval or in set notation. If you wanted it in interval notation, it includes 5, so you're going to have a bracket, -5, sorry, that should be -5. -5 to infinity, because it keeps on going. So there's two different ways you can write it. I was telling students in the past 3 years, students have been coming back saying, they're showing me this notation, Mrs. Schutz. I don't understand it, because Saxon would always put it in the set notation. Colleges were showing it in interval. So then I start telling them interval, and then Lindsay comes back and says, well, the teacher said something about the set notation. I said, well, I'm surprised because the question said, write your answer in interval notation. So I don't know, be flexible, be able to look at both and understand both. If I were to ask you about the domain, or not domain, we just did domain. If I were to ask you about the range happens to be the Y values. And if I look at the Y values, what's the highest Y value that you get, the largest? 6, and the lowest value is infinity. So you can state it this way, Y now instead of X, because range deals with Y. Y is an element of the reals such that Y is less than or equal to 6. That's what I get on my graph. As I look at that, I could change that into interval notation. In interval notation, your smallest value is -infinity, and it goes up to 6, and it includes that value. Now, if I did not want it, if it did not include the value, what you would end up having is you would have this right there. Instead of being a closed circle, it would be an open circle. That's the difference between the two, whether it's included or not included. Okay, I don't think they have you calculate much. Oh, yep. We will revisit that just a little bit. Right now, you're ready for number 15, which is composite functions. You don't talk about domain until you get to problem number 29. So instead of getting out of order on your problem set, I'm just going to go ahead and talk about composite functions. And then when we get to 29, I can show you some examples of how to find domain and range for specific equations. So the next thing we have is composite functions. All right, we have already had functions such as f of x, and I can tell you that f of x is equal to x minus 1 squared. So if I asked you, what is f of 3, what would that have a value of? You would put 3 in for x and square. So if I put 3 in for x, you're going to get 3 minus 1 is 2, 2 squared is 4. So f of 3 would have a value of 4. And remember what you do is you take whatever is in the parentheses right here, you go to the original function and you put it in for x. So you did that. You've done several problems like that so far. What if I also told you that I have this other function, so I'm going to call it g, not to be confused with h. So I have two separate functions, and I'm going to tell you g of x is equal to 1 over x. And you would be able to tell me what is g of 3 equal to. That's equal to 1/3. When you start talking about composite functions are going to look something like this. They're going to ask you, what is g of f of 3? Now, another way that you can see that you're going to see it in the Saxon textbook or in the trig textbook, this right here means the same thing as g of f of 3. I think you saw that a little bit last year because I said we do not want to refer to that as goth, fog, any of that stuff. So I know I talked about that because I remember Jaden saying goth and fog. So g of f of 3 means the same thing as this first function I have right here with the parentheses. Now, just like normal orders of operations, you work with the innermost set of parentheses first. So this is telling me I want to find g of whatever f of 3 is. Well, I already found f of 3. What is f of 3? 4. We found out right here that f of 3 has a value of 4, so I can replace this right here with what it is equivalent to. So g of 4 is what I am actually looking for. So then I'm going to take my g function, which was 1 over x, and I'm going to replace that x with 4, and your answer is just 1/4. So that's a composite function. When you have to use one function, take that answer and put it into the other function. Okay, what if I ask you to find, and I don't know if the color coding helps, what if I ask you to find g of f of 1/2? So I want to find g of, oops, that should be in the other color probably, because it's designating the g function. What if I ask you to find g of, and then I need to find f of 1/2? What's the first function we're going to use? Yep, the 1/2, f of 1/2. So if I remember over here, if I want to find f of 1/2, your f function, if you look up over here to the top left, was going to be your x value minus 1 quantity squared. So I'm going to take this 1/2 and put it in for x. What is 1/2 minus 1? Negative 1/2. And if I square it, you get 1/4. So now what I want to do is I want to replace that for that f of 1/2 value. So they're asking you to find g of f of 1/2, which has a value of 1/4. So I need to take my g function now, and my g function is 1 over x. But what am I going to put in place of x? 1/4. What is 1 divided by 1/4? 4. Oh, I better get rid of that equal sign. So your answer ends up being 4. Now sometimes, well, just a minute here. Okay, so if we keep those same two functions, we've calculated what g of f of 3 is, what g of f of 1/2 is. What if I ask you what is g? I'm going to just go ahead and color code it right off the bat. What is g of f of 1 equal to? So what are we going to do first? We're going to do the innermost first, so we're going to find f of 1 first. What does f of 1 have a value of? It's going to be 1 minus 1 squared, so you're just going to get 0. Now what we are looking for is we are looking for g of 0. But if I find g of 0, what are we going to get? Undefined, because that's going to be 1 over 0. So your full answer is going to be undefined. What if I ask you to find, now this is where it gets tricky, what if I ask you to find g of f of x? Well, what's f of x? Yep, the quantity x minus 1 squared. So they're asking me to find g of, well, f of x has a value of x minus 1 squared. So I'm going to take my g function, which is 1 over x, and I'm going to replace that x value with, I'll show it like this, x minus 1 squared, which overall the whole thing looks like 1 over the quantity x minus 1 squared. So it gets a little more tricky when you do not have your numbers. Yep. What if I ask you this? What is g of x? Sometimes you might see your composite function like that. Well, what's g of x? This right here. 1 over x. So they're asking you to find g of 1 over x. So I'm going to take my g function, which is 1 over x, and in place of that x, I put this value right here. So I'm going to put 1 over x, and all of that simplifies into just x. Now keep in mind, you can find g of f. You sometimes can find f of g, so you just got to be careful which way it's asking. Okay, so we look at this one. They're going to ask you to find two things. They're going to ask you to find g of f of x and f of g of x. So we'll start with this first one. They're going to ask me to find g of the quantity x minus 1 squared. So your g function is 3 times your x value plus 1. I'll put it in brackets. And that x value, I should change the color of that if I'm going with color throughout. Try to keep things straight for you. So that x value is going to be the quantity x minus 1 squared. So we can simplify that. If we simplify that, we're going to get 3. And the quantity x minus 1 squared is going to be what? It's going to be minus 2x because there's a minus sign there. And then plus 1. So then you end up with 3x squared minus 6x plus 3 plus 1. So then your overall answer just becomes 3x squared minus 6x plus 4. Okay with that? Right, so the other thing they could ask you is to find f of g of x. So I want to find f of whatever g of x is, and g of x is 3x plus 1. So I'm going to take my f function, my f function is x minus 1, and I'm going to square it. But in place of the x, I'm going to put 3x plus 1. Okay, so far of where I am with that setup. All right, so I'm going to solve inside the parentheses first, or the brackets. So if I solve inside the brackets first, the ones cancel out, and you're just left with this 3x in there. What is 3x squared? Yeah, very good. 9x squared. Now, sometimes they will have 3 functions in there, and you might be looking for f of g of h of x. So we would need to calculate those as well. So we'll get into what some of those will look like. All right, questions over that? Are you good? We'll come back tomorrow, or you could try 15 and see what you get for answers. And then we will see what you got and continue working on them, because you got a lot of these that you're going to get practice with. Keep these binders, take it to college.